I'm going to go through the mole homework just to make sure that you know how to do stuff. All right, so the first worksheet was a mass worksheet, the mass of the mole. Let me make this a little bigger. I don't want to do that. I'll make it a little bigger. So remember that all the molar masses come from the periodic table. I can make the periodic table bigger. All right, so the first substance we had was lithium iodide, right? So what we're looking for there is just to review with you. So if you're looking at molar mass, right? So there's the mass of lithium, it's that number at the bottom, and iodide's over here, and the mass of iodide would be at the bottom as well. So when I get the masses for these, as we're going through them, that's where I'm getting them. It's the bottom number on the periodic table. Okay? All right, so we can move on from that now. So for lithium iodide, the way you get credit to show your work is we'll put our lithium there, we'll put our I there. So lithium was 6.94, iodine was 126.90, and then 133.84, and our unit is grams. So a couple things when you're adding, right? We talk about significant digits. They're going to talk about it in the first semester, but I'll reinforce it here with the second semester on the first day. When you're adding, right, you always go to the last or the least accurate. So both of these are accurate to the 100th place. So our answer will be to the 100th place. It doesn't matter how many digits there are. When you're adding, it goes to accuracy. Okay? All right. Or precision is probably a better way to say it. So that's an example there. So PbCO4 will do the same thing. So we have Pb, we have C, and we have 4 times O. Right? Lead was 207.2. Carbon is 12.01. And 4 times oxygen is 64.00. So when I add all these up, I get 283.2 grams. Now you'll notice here that this is to the tenths and the hundredths and the hundredths. Tenths is less accurate than hundredths, so that's why when we add them all together we go to the tenths. That's a significant digit thing. Okay? I won't be super strict because you haven't had it in the first period, but when I do answers, I'll try to do like that. Now this sheet had an answer key at the bottom. I'll have to look at it, but I don't know if they really accounted for significant digits at all. All right, and the last example I'll give for this, for the one that's a little different, is number 5. So remember this 3 here gets distributed to the parenthesis. So now I have 3 times N. I have 12 times H. I have a P. And I have 4 times O. So 3 times N would have been 42.03. I get 12.12. 30.97. And again 64.00. When I add them all together, I get 149.12 grams. Again, you'll notice that each of these is to the hundredths, so I round it to the hundredths. And I've got my unit grams because that's what it is. All right, so the first sheet, pretty easy. All right, you should be able to get through it no problem. All right, the second sheet. So the second sheet is doing mole conversions. Now again, we have our mole roadmap here. Remember moles to the middle. And if we're going to go from mass to volume, we'd have to go through moles first. All right, so I'll give you some examples of how to do it, but please refer back to your roadmap here when you're doing things. All right, so this one's set up a little differently. So I set it up so you'll know what to do. So starting moles, right? That's your given. Remember, your given is whatever has numbers in it. So I've got 3.24 moles of Mg, right? And I'm trying to go to magnesium atoms. Remember, atoms are particles because they're real, right? So that'll be our particles. So our conversion, I'm going to put mole in the bottom because I want to get rid of it. And then when I'm doing particles, I've got Avogadro's number. It's 6.02 times 10 to the 23rd. When I do that, my moles cancel out, right? And I multiply that. So remember, whenever you see this line down the middle, that means multiply. So I'll end up getting 1.95 times 10 to the 24 milligram atoms. Okay, so when you did this problem, you may have got 19.5 times 10 to the 23, but remember I have to fix my scientific notation, right, and to make it correct. All right, so that's an example of that. The next one I'll do the next one down. So again, I'll draw my little line here. That's my start, my given. Right, so I've got 4.86 times 10 to the 4 grams of magnesium. Right, so if I come back up here, right, I'm starting with, here's my start. Right, I'm trying to find moles, so that's my finish, so I'm going in that direction. Right, so I'm trying to find moles. Put that here. And then my molar mass, 24.31 grams. Remember, molar mass I found on my periodic table. Right, so if I came to my periodic table, I would have found that right there for magnesium. That's where I got that 24.31. Okay. All right, so when I do this, I can cancel out my grams. And I can go ahead and multiply across. I'll get 2.00 times 10 to the 3 moles. Right. So multiplication and division, I go to the number of digits, not the accuracy number of digits. So for instance, I had 3 digits here. Oh, let me make that right. I had 3 digits here. So I have 1, 2, 3 digits here. Same thing with the first one. I have 3 digits here, and I have 3 digits here. So multiplication, division is number of digits. Addition, subtraction is accuracy. I'll do this one down here. So it starts to transition where it doesn't remind you. Okay, so when we look at this, remember, in this box goes the given. The given is usually something that has a numerical value. So I'm going to start out with my 57 liters, right, of H2. Right, and it says how many moles. So this is my start, and this is my finish, right? I go mole, right? So if we come up here, liters, make sure it says. So liters is volume. So this would be my start to my finish. That's how I'm going to read my roadmap. All right, so let's come over here. So down here, I put 22.4 liters. All right, when I do that, I'll get 2.5 mole of H2. Remember, I had 2 digits here, so I have 2 digits there. Okay, That's the way we do our significant digits if you're new to that game. All right, just a couple more. This will be really quick. For number 11, I think I helped you with. Okay. So same thing. This will be my start, right? How many, the question, and this will be my finish. Right, so I have 45.6 grams of sulfur. Now if you look at here, so let's come back up here. So let me erase some stuff here. My start is grams, and I want particles. I don't have a line that goes from there to there. So I have to do two equations. I have to go from here to moles, and then I've got to go moles down to there. So I need two equations for this. Right. So first I'm going to have to go to mole. Right, and we know that the molar mass for sulfur is 32.07 grams. And when I do that, I'll get 1.42 moles of sulfur. And now I'm going to have to go to molar particles. So this is my first equation. My second equation, then I'll put Avogadro's number here. Okay, so when I do that, I've canceled out my grams, canceled out my moles, and you should get 8.54 times 10 to the 23rd atoms of sulfur. Okay, so that's how you do that. Two equations. The last thing I'll help you with is density. Remember, density is mass over volume. Right? Our molar mass is in grams, and our molar volume is in liters. Or we can say it's grams over liters. So density of helium. So again, if we looked at the periodic table, we could see that helium is 4.00 grams, and the molar volume is 22.4 liters. So that's all you have to do here. Right, when I do that, I get 0.179 grams per liter. Again, I have 3 digits with the 4.00, so I have 3 digits here. Okay, well, I hope that was helpful. Let me know if you have more problems. There will be a Zoom at the end of the day in case you need more help. Talk to you later. Bye.